Okay, so good afternoon, professors. We're Team 1, and we are here to present the roadmap for the Mosaic project. So 6 months ago, the streamlined logistic required a thorough move. So on paper, this combines our high volumes freight network with their high margin zero failures code chains. But in realities, we are currently operating as the two disconnected entities, and this is costing us monies. We face a variety of problems. So the streamlines run on rigid legacy SQLs, while the moves run on flexible non-SQLs and high-speed IoT sensors. Because these systems cannot talk to each other, our VP operations, Market Throne, is blind. We are recently losing about 1.2 million on stocks in a single afternoon because we can just detect their cooling failures in times. And simultaneously, we're in a technical deadlock. Our data scientist Elena's cannot build the predictive AI we need because the data is dirty. Yeah, we cannot just simply clean it because of the FDI regulations mandate we have to preserve the original raw records of the audit. And to make matters harder, we must solve this while cutting the IT operations expense by 15% and relying on our existing SQL-focused teams. So our proposals breaks this deadlock with a cloud-first data lakehouse architectures. And now I'll pass time to my teammates to talk it about more.
Here I will explain our overall system architecture and how it supports both business and technical requirements. Our proposed solution is based on a cloud-based data lakehouse architecture. The core idea is to centralize all data into a unified platform while keeping cost, scalability, and maintainability under control. The data architecture is organized into three layers: raw, curated, and serving. First, the raw layer stores our original data in its native format. This includes data from the legacy Circle systems, MongoDB documents, and IoT sensor streams. All data is ingested directly into this layer using CDC pipelines and streaming connectors. The data in this layer is append-only and immutable, which ensures regulatory compliance. Next, the curated layer is responsible for data cleaning, standardization, and feature engineering. In this layer, we handle issues such as missing temperature values, abnormal GPS records, and inconsistent formats. Based on business needs, relevant data sets are transformed and validated before being stored here. This layer provides trusted and high-quality data for analytics and machine learning. The serving layer contains high-structured and optimized data sets. It is designed for dashboards, operational reports, and management KPIs. Important analytical results and alerts are also stored in this layer to support fast query. To unify Circle and non-Circle systems, all data in this lake is managed through a centralized metadata and schema management service. By using schema rich and open table formats, both relational and semi-structured data can be curated using standard Circle. This allows existing Circle developers to continue working without learning complex new tools. For IoT data, we adopted a lightweighted streaming architecture. Sensor data is ingested through a message query and processed using microbatching every 20 seconds. Real-time rules apply to detect abnormal temperature trends, enabling alert generation within 30 seconds. These alerts are immediately sent to operations teams and also stored in the serving layer. For local data governance, we adopted a lightweighted hybrid management approach. IoT data streams are sent directly to the cloud due to their high volume and real-time requirements. Data from legacy Circle and MongoDB systems is first generated and maintained in on-premise databases, and then synchronized to the cloud through CDC pipelines. This minimizes disruption to existing business operations. Key metadata, data governance documents, and critical analytical results from the curated and serving layers are periodically backed up to local systems. This provides additional control, auditability, and disaster recovery capabilities. Then let me introduce our benefits of this architecture. For scalability, Cloud storage supports athletic extension and append-only ingestion, allowing the system to handle growing data volumes efficiently. For cost control, we use low-cost object storage, optimized data partitioning, and near real-time processing instead of expensive file streaming systems. Finally, for maintainability, most infrastructure is managed by cloud providers. The platform remains Circle-centric, reducing training costs and long-term operational risks. Overall, this architecture balances performance, compliance, cost, and usability to support both current operations and future AI initiatives.
Hi everyone, I'm Shibo. I'm covering ROSI, the ingestion layer, and the raw immutable zone. So let me start with the key problem. In Project Mosaic, we want fast monitoring and future AI, but at the same time, we must keep the original records for audits and compliance. So for us, the raw zone is basically the evidence layer. We store what the system received exactly as it arrived. Now, what do we ingest? We have three main streams. First, the high-frequency IoT telemetry from reefer trucks. Things like temperature, humidity, vibrations. This comes in non-stop and it stays at high volume. Second, GPS and operational tracking data. This one can be messy. You might see missing values, with jumps, or impossible speeds, but we still capture as it is. And third one is legacy operational systems, streamlined SQL data and MongoDB documents. For the SQL side, we use replication or CDC. We keep a change history. For MongoDB, we keep document versions. And again, these are the same rules that landed first and don't transform yet. So the raw zone follows three simple principles. And the first principle is append only. Nothing gets overwritten. Because if a value changed later, we store it as a new record. This lets us prove what we had any point in time. And principle two is no force schema. We don't try to flatten or feed everything into a strict table at ingestion, especially for JSON and sensor data. Forcing sigma too early can drop fields or lose context that we don't want to, especially we don't want. Principle three is standard ingestion metadata. Think of it like a shipping label. We add ingestion time, source system, and IDs like truck or sensor ID. This is what enables lineage later. We can trace any dashboard number or model feature back to exact raw records. And finally, we keep a clear boundary. The raw zone doesn't do KPIs. It doesn't clean data, doesn't smooth sensor noise. All of that happens downstream in the curated layer. So here is the one-line takeaway. Raw is evidence, curated is insight. That's how we stay compliant and still move fast for dashboards and AI. Thank you.
Now I will cover section 3, the pipeline, processing, curated layer, and future store. My section takes the raw data from the raw zone and turns it into trusted usable data for dashboards, alerts, and AI models. Our pipeline processes data through three stages. First, data cleaning and validation. We run rule-based checks on all incoming data. Temperature values outside -80 to +60 degrees get flagged. GPS records with impossible speeds like high 100 km per hour for a truck get flagged. Importantly, we never delete bad records. We the quality flux and the reason field so the original data stays intact for FDA compliance. Second, standardization and integration. Streamline use SQL, former will use MongoDB. We map both to common schema, unify all IDs, and convert units to Celsius, kilometers, and UTC. This gives Marcus one consistent view of all 1,050 trucks. Third, aggregation and feature engineering. We group sensor data into time windows, 20 seconds for real-time alert, 5 minutes for the dashboard, and hourly and daily for reports. We also engineer features like temperature gradient and validation risk score for Elena's AI model. The future store is where pre-calculated trusted metrics live. It has two modes: batch futures for model training and real-time futures for live decisions like route changes. Every future has fully traceable back to the original sensor reading, so we can always prove where a number can form. We also provide an SQL interface, so our team can query futures without learning new tools. For the red alert system, we process IoT data in 20-second micro batches. We apply anomaly detection rules to each batch. If the average temperature goes out of range or 3 consecutive windows show a rising trend, an alert fired to the operation team within 30 seconds. This is exactly what Marcus asks for. To summarize the business value, FDA compliance is fully maintained because raw data is never modified. Every clean record links back to the original. On cost, we only use stream processing for 30-second alert. Everything else runs as a batch, cutting compute costs by about 60% compared to always-on streaming. This directly supports the 15% OpEx reduction target, and SQL-centric design means South's existing team can maintain the system without hiring new engineers.
Project Mosaic is not only a technology project, it's also a compliance project. After integration, we manage two types of sensitive data. First is personal identifiable information such as driver's names, phone numbers, and payroll data. Second is pharmaceutical telemetry data, including temperature logs, humidity readings, and custody records. Pharma move just follow FDA 21 CFR Part 2. If we fail to meet these rules, shipments can be rejected, and operations may stop. At the same time, business teams need fast dashboards and real-time alerts. AI models also require stable and clean data. So our goal is clear. We must protect privacy, follow regulations, maintain audit transparency, and still support fast business operations. This is why a strong governance framework is necessary. Good governance starts with data classification. Not all data has the same risk, so we divide data into 4 levels. Public data includes summary reports and KPIs. Internal data supports daily operations. Sensitive P2 includes driver and payroll information. The highest level is regulated pharmaceutical data. After classification, we protect the data using a layered architecture. The raw layer stores original data in append-only format. It cannot be changed. The curated layer prepares clean data for analysis. The feature store supports AI models with version control. The serving layer powers dashboards and alerts. This design separates compliance data from daily operational views. It reduces risk while keeping work efficient. Access to data is based on job roles. HR can see payroll records. Operations managers can view delivery contact details. Data scientists work on clean data, not raw personal data. Sensitive fields are masked. Data is encrypted both in storage and during transmission. Every access is logged for review. To meet FDA rules, raw data is immutable. It cannot be changed or deleted. Every dashboard result or AI output can be traced back to its source. We also monitor the system continuously. If there are unusual access attempts or large downloads, alerts are triggered immediately. Even with strong governance, performance remains fast. Dashboards load quickly. Alerts are real-time. AI modes run smoothly. Governance works quietly in the background. It protects the company while allowing innovation and growth.
Hello, I'm Xiaoxie, and next, to conclude our proposal, let's address the critical challenge set by the board, reducing IT OPEX by 15% while delivering advanced AI. An always-on streaming system is simply too expensive, so we made 3 strategic decisions. The first is microbatching. We process data in 20-second intervals. This generates red alerts within the required 30 seconds window, but cuts compute costs by roughly 60% because we don't pay for idle service. And second is about the tiered storage. We automatically move historical IoT logs to low-cost cold storage after 90 days, retaining FDA audit trails affordably. And third is about the serverless computing. Our pipelines scale to zero when inactive, completely eliminating the waste. And next, we address the CTO's concern about her team's skill set. We cannot afford a completely new engineering team, so our solution is a SQL-centric lakehouse. By using the schema on red technology, your existing IT team can query complex MongoDB JSON data using the standard SQL they already know. No extensive retraining is needed. And furthermore, our unified feature store allows data scientists to reuse pre-calculated metrics like average temperature rather than rewriting cleaning code for every new model. This dramatically reduces our long-term technical debt. And to mitigate operational risk, we propose a rapid 6-month phased roadmap just shown on the screen. And phase 1 is about the foundation. We deploy the immutable raw zone to secure immediate FDA compliance and stop the data swamp. And phase 2 is the visibility. We solve the fleet's blindness by launching the 30-second red alert system and the unified dashboard. And phase 3 is about the AI optimization. We finally unlock the acquisition's strategic value by deploying the predictive maintenance and dynamic routing models. So in conclusion, our project resolves the technical conflict between the legacy SQL systems and cloud-native NoSQL environments. We have ensured strict FDA compliance. We have enabled real-time decision-making. And most importantly, we have empowered the AI team while strictly respecting the 15% budget constraint. This architecture transforms a chaotic data challenge into a massive competitive advantage. We recommend the immediate approval of this roadmap to ensure the platform is operational before the next physical quarter. Thank you.